This is just a bit of an experiment with this skincare tube ballast thingamajig that I got from Electronics Goldmine. Just an experiment to see if running these F65 lamps on it is putting more stress on it than running an F4 T5. Because one problem with these cheap blocking oscillator type ballasts is that if they're unloaded, the inductive spiking from the ballast switching can actually fry the switching device. And that can also be a problem if the potential across the lamp is too high, because the lamp is effectively acting as a GDT to limit the inductive spiking or inductive spikes from the ballast by, again, acting as a GDT to basically just serve as a potential clamp. And as see by the pile of scope probes, have the oscilloscope looking at it. Its top trace is the potential between the collector of the switching device and ground. Blue trace is potential across the lamp. Those two are both for scope safety reasons. I'm using 100x probes for those. And the purple trace is the potential at the central node of the RC chain there that just basically serves for tuning the ballast. Just looking to see if there's any kind of oddball potential bits there, and don't really see much. Also, the operating frequency of the ballast is about 63 kilocycles. Peak potential across the lamp, or peak to peak potential across the lamp is 134 volts. RMS is about 44 volts. And those other two are just the potentials across the transistor. And a peak with an F65 is 65.6 volts. And one thing to note, if you do design something with one of these ballasts, they are from a piece of consumer electronics, so don't expect the highest quality. It is paperboard, PCB, blocking oscillator ballast topology. Ordinarily, I prefer to see something like a Royer or a similar circuit that used AC to drive the lamp. Although with a DC ballast like this, I might experiment with heating the cathode, which I mentioned in the previous video I did on this. But yeah. But then again, the thing was cheap. It was only less than $2. So yeah. And also the it has this timer circuit because the ballast thermal management is not such that it can run continuously. The after about a minute of running, even with a F65, this switching transistor heatsink gets fairly hot, and with an F4T5 it runs almost too hot to touch, hence the timer. But one thing what I'm planning on using this for is, and hence why I have the switch brought out to wires now, is with something like a button with a glow-in-the-dark actuator as a manually actuated emergency light, so that this thing can be continuously powered and not use very much electricity at all. But yeah. And also, word of warning, these do put out enough electricity, or the electrical potential at the output is sufficient to cause dielectric breakdown of human skin, so it can give you a fairly bad shock. And depending on how you hook it up, it might kill you, so I advise against trying that. And I might also replace the red LED with a brighter one, because this predates super bright LEDs with things like indium gallium nitride and aluminum indium gallium phosphide dye chemistries becoming fairly common. I think this might use one of those gallium arsenide dye architectures, which were about the best that were available prior to modern super bright formulas, which produced a whopping 0.3 candle power or something like that. Something fairly minuscule. So yeah. But it's a thing, and I got it for experimentation purposes, which is what I'm doing. And one thing I've noticed, there's also some ringing on the part of the drive winding stuff there. That might also be something to look for. There's the peak potential, yeah, about 70 volts. And it just auto shut off. Oh, one bit of an addendum is that with the F4T5 configured as it was, granted this isn't the same lamp that I was using with my thermal testing, the heatsink focus. The heatsink is was slightly cooler at the point where the ballast automatically shut off than it was when using that F65 lamp. But then again, this is also a different lamp from what I was using with the testing. This is some generic Daylight Aurora branded lamp that was in a little 4 watt fluorescent fixture that I've had for as long as I can remember. I used to use it a lot as an emergency light back before I installed the solar farm. Whereas with the thermal testing I was using some generic Chinese General Electric branded lamp, which I couldn't find, hence the reason why I used this. So it might also depend on the particular lamp you use for this thing. Just found the General Electric lamp and hooked it up, and there it is in use. And peak potential across the switching device is even higher with this one, about 75 volts. Also, triggering is a bit finicky, but then again I think a lot of that's just noise from this being a fairly crappy circuit. And it looks like it is actually driving the lamp with AC, so I might not even need to fiddle around with the try to drive the thing with DC, although it is instant start, which is not very good. And yeah, the heatsink is really toasty, so I think it's probably just a matter of my using that particular lamp. It just happened to be running fairly cool. So yeah. So yeah, it looks like this thing will work good with F65s, and depending on also probably adding or putting on a bigger heatsink or supplementing this one would be a good idea. But I'd also experiment with tweaking the cycle time of the shutoff circuit a bit higher so it would run for longer. But I know that'd be just stuff for experimenting with.